can you please confirm me whether you are able to see the screen and is my voice audible properly? Hello. Naveen, can you please confirm me whether you are able to see the screen? Hello. Hello. Yeah, good evening. I hope you are able to see the screen and my voice is also audible properly. If there is any problem, you can unmute and speak. Fine. So, so in today's class, we'll be talking about a brief introduction towards the concrete technology, and we'll see a couple of things related to the concrete technology. So before I talk about what are the things that I'm going to cover in the concrete technology, let me show you what are the things that I'm going to cover on a whole. By the end of this complete course, what exactly you'll be understanding. So that I'll be showing now. So you can call it as a syllabus or you can also call it as a curriculum that I'm going to cover the next 1 month or 1.5 month duration of time. So initially I'll start with the basic concepts of cement and admixtures. So I'll be talking in depth the details of what is a cement, what are the different manufacturing process of cement, so how to work with the cement, the test process of cement, and then we'll also be looking towards how to work with the admixtures, what are the different types of admixtures, and then in the second unit, we'll be talking about the aggregates part, that is the coarse and fine aggregates parts and their related test measures, and then how to use the aggregates in the concrete preparation. And then we are going to look towards the fresh concrete, where the concrete is freshly mixed. So we'll be talking about how to work with the fresh concrete, what are the different tests that are available to work with the fresh concrete. All these things we'll be looking down. And then we'll be moving towards understanding of the hardened concrete on a large scale. What are the test methods that you can do in hardened concrete? How to evaluate and hardened concrete, and how to work with the concepts of elasticity, creep, and shrinkage. And finally, we'll be moving to the mixed designs of concrete along with the discussion on special concrete. So we have different types of special concretes such as fiber reinforced concrete, self-compacting concrete, pervious concrete, glass fiber reinforced concrete. All these are called as a special concrete. So we'll be talking about that also, followed by the mixed design process. So these are the topics that we are going to see on a large scale. But again, here I need to go with the micro scale divisions in each and every subtopic. So, but on a large scale, we'll be talking about the cement, aggregates, the fresh concrete, hardened concrete, and the mixed design of the concrete. That's how we are going to work in this concrete technology course. Fine.
Uh,
So no,
sorry,
yeah,
so,
please.
so, sorry, sir. These 4 minutes I was in mute. I didn't hear your voice.
So now, are you able to hear my voice?
Yes, sir. Now it's okay.
Yeah, fine. So can I continue now?
Yeah, please, sir.
Yeah, fine. Thank you. So these are the 5 units that we are going to look towards. That is, we'll understand how to work with the cement, and then we'll move to the understanding the concepts of aggregates and the fresh concrete. And once we understood the concept of the fresh concrete, we'll be looking towards how to work with the hardened concrete and what are the different test measures for the hardened concrete. And we'll also be looking towards how to work with the mixed design of the concrete along with the special concretes that we have. So we have different types of special concretes. So I'll be giving an overview of how to work with those special concretes by the end of this course. Now, here, in order to work with the concrete technology, like you need to refer a couple of textbooks. So these are the three textbooks what I usually suggest. So one is Concrete Technology by MS Shetty, which is the most commonly used textbook. So maybe you can also refer to these textbooks. However, I'll be sharing the soft copies of all these three textbooks by the end of, once after we complete this particular session. So you can have a look into them. Along with these three textbooks, I'll also suggest to go with, suppose for BTech students, I'll suggest these three textbooks. If the students are from MTech or if the students are from PhD, I'll be suggesting couple of other two textbooks also, which are called as The Properties of Concrete, which is written by A.M. Naivalli. And the second one is Understanding the Microstructure, Properties and Materials of the Concrete. So these are the two textbooks which helps us to understand the concrete in a much deeper details. So in this course, I'll be taking the references of each and every unit from all the 5 different textbooks. So I'll be taking out the best ones where I can explain in a very good possible way. So, and then I'll be talking about all these 5 textbooks. So, but if like for the MTech students and for PhD students, I would refer to go with the 3 textbooks. That is, the first textbook which you should refer is The Concrete Technology by MS Shetty. And the second textbook which you need to refer is The Properties of Concrete by A.M. Naivalli. And the third textbook which you can refer is The Concrete, which basically talks about the microstructure, properties and materials, which is written by Kumar and Mehta. Okay, these are the textbooks that you can refer to. Fine. So now here, what we are going to look towards is we'll be talking about the first unit, which is a discussion related to the cement. So we'll be in understanding on a large scale how to work with the cement, what is the chemical composition of cement, what is a hydration and how the different stages of hydrations are available. What do you mean by the hydrated cement? And then what is the structure of the hydrated cement? And we'll also be looking towards what are the different tests that you can do on the cement, both in the laboratory conditions and in the field conditions. And then we'll also be talking about the different types of cements that are available for us. Along with that, we'll be also discussing on the admixtures topic in the cement itself. Okay, what are the different types of mineral admixtures that we have and the chemical admixtures that we have, and how we need to work with those mineral and chemical admixtures when we are preparing a concrete. That's how, on a large scale, we are going to cover in the first unit, that is cement topic. Fine. So first, let me talk about the Portland cement, or you can also call it as a cement. So before I talk about the cement, let me have a brief introduction towards how the concrete structures has got evoluted over a period of time. So I can call it as the evolution of the structures. Here, I don't mean to say the concrete structures, but I just mean to say the evolution of structures. It can be made up of any material, but let's see how the structures has got evoluted over a period of time. So initial days, like if you talk about the very old days where the people used to live, they used to live on the trees, okay, which we generally call it as a tree huts, right? So people used to live, the medieval people, the old age people, they used to live on trees to keep themselves safe from the animals or the animals which are roaming in the forest. So that's, you can call it as a very beginning stage of the structures. So which is basically on resting ourselves on the top of a tree. Then over a period of time, we have got evaluated and then we have started constructing certain kind of hut kind of structures on the top of tree itself. So this is how the first structure of the construction, first structure that we as a humans have used. So probably this could be the first structure where people used to sit, or where people used to stay on the top of the trees to keep themselves safe from the wild animals which are roaming in the forest. Then we have got a better idea. Then we started moving into the caves. So where we called that kind of era as cave era. So where people used to go and stay inside the caves to keep themselves away from the rains or to keep themselves away from the natural habitats. Suppose if they are staying on the trees, okay, there is a chance that if a sudden rainfall happens, so maybe the people might not feel secure over there. So then the people have started moving into the caves, which we call it as a cave era. Then over a period of time, so then we have shifted towards the construction of houses basically by using the clays. So we had the clay structures, and again, these clay structures are not a large scale clay structures as we see now. They are just constructed the structures by using the clay on the shapes whatever they require. Now, if you observe the shapes of the structures that they are constructing here, they are almost irregular shapes. They cannot define the shape of the structure also. So it's impossible to stay in these kind of structures. But again, so that's how people started constructing the structures by using the material called clay or the sand, whatever that is having the sticky properties to the sand. Like clay, we also have other types of sand where it will have certain kind of sticky nature or the cementitious property will be having to the sand. So such kind of materials they have used, and people started constructing the houses. And then over a period of time, in the clay structures only, we have got much better modified structures. That is where we can see the Roman structures, the early modern structures you can see. So all these like the forts, the big forts, all these are there. So they all are constructed by using the stones and the red clay or the black clay only. So that's how we got evaluated. And then over the past 600 to 700 years, we started constructing the structures based on the concrete. So that's where the concrete structures has come. Then after the concrete structures, we are again moving towards the sustainable construction materials, like the construction of structures without having any kind of cement or with utilization of low quantity of the cement. So we have got many modern buildings such as green buildings, we are calling it as, and then low carbon buildings. So all these are the modern structures. But if I have to speak roughly about how the structures has got evaluated, I can keep in these five figures, initially starting from the trees and then moving into the cave era, and then moving towards the construction of structures by using the cementitious materials, maybe the clay or the red soil, whatever that they have at that point of time. And then we have moved to the construction of the forts, and then we have come to the concrete structures. Now, this is where we are going to focus on. So this entire course will be focusing on how the people had started working with the concrete structures, who actually invented the cement, what is the composition of the cement, why we are calling it as a concrete structures. All these things we'll be looking towards by the end of this particular unit. So here, if we understand the evolution of structures, so we have got to know that there are different materials that we have used to construct these structures. You can see the huts which are constructed with wood, and then you can see the caves which are naturally available with the in the form of stones, and then we have used the clay, and then we have used the concrete members. But here my question is, why is it important to study the concrete technology, or why is it important to understand the concrete structures itself? So here, in order to understand or in order to know the reason why we need to study the concrete structures, we need to question a couple of things for ourselves. So the first question goes in this way: can we use a wood, or can we use the wooden members to build a dam? So obviously the answer is no for this. So we cannot use wood to construct the dam, because we know there are some possible problems with the wood, because wood is prone to the water, or it might get it might get fallen off, or it might get peached away. So all these things will happen with the wood. The quality of the wood will get decreased when the water comes and strikes the wooden structure. So that we have seen. So we cannot construct a dam, or we cannot construct a large scale constructions by using a wood. That's one thing. And then comes the next factor, which is, can we construct or can we use wood to construct a furnace? So furnaces are something, suppose if you see the cement manufacturing plants, we have the huge concrete furnaces will be there, where the concrete will be, where the cement will be heated up to a temperature of 1400 to 1600 degrees centigrade. They are all furnaces. So basically inside the furnace, we have the elevated temperatures. So when we have the elevated temperatures inside the furnaces, so in such cases, we cannot use the wood to construct the furnaces, because wood is sensitive to fire. So again, the problem comes here. And the next question that we need to answer is, can we use the wood or steel to construct the pavements? Pavements are nothing but the roads. So the obvious reason is, we can never construct a road, or we can never lay a road or a pavement by using the wood and steel, right? There is no possible scenario for this. So the answer for all these three questions is a complete no. So then what is the alternative material for this? So what is the alternative material to construct a dam, to construct a furnace, to lay the pavements, or to construct a large scale structure? So obviously the alternative material which we have is the concrete. So we have the concrete dams, we have the concrete furnaces, we have the concrete pavements. So this is how the importance of the concrete structures will lead to. So that for those reasons, it is important for us to understand the concrete structures or the construction of the concrete structures.
Excuse me,
But
sir.
again, yeah, please go on.
Sir, would you move aside, downside this menu box which is showing that recording and all?
So is it showing for you?
Yes, sir.
Just give me a minute. I'll just stop this. Are you seeing still?
Yes, because the
Let me.
recording video mode, all that
Yeah, yeah.
menu is coming on the middle of the slide.
Actually, I have removed that one from my slide. So is it still visible now?
Yes, sir.
I'll do one thing. I'll just stop the screen sharing and then I'll restart it once again. Let me have a cross check once again. Is it now visible?
Yes, sir.
Now now I have minimized it. Are you seeing now? The problem is same.
Yes, sir. The same problem.
I think I have actually minimized it, but I don't know what exactly is the problem. Let me do one thing, okay? I'm just
Yeah. Yes. Now you said it's gone, sir.
okay, fine. And so maybe I think it is taking some time. So
Okay.
yeah. So I think now you are not able to see.
Yes, sir. It's comfort now.
Yeah, fine. So the question, the answer for all
Sir,
these
it came
questions,
again. It came again, sir.
probably maybe sometime after it will go, I think so.
Maybe. Okay, sir.
Probably. So I think you are able to see the screen comfortably, right? Like there is no
Yeah.
obstruction that you cannot see.
Uh, yeah. It's coming on the screen. That's the problem.
Okay. So I think it is
Yeah.
not
Now it has
showing.
gone. Now
Okay,
it
fine.
is gone. Yeah.
Yeah, fine. So the answer for all these questions is yes, we do have the alternative material for the construction of wood or any kind of structures. So basically, the alternative material which we have is the concrete as the alternative material. But if you ask me, don't we have any problems with the concrete structures? Yes, we do have the problems with concrete structures. We do have certain kind of case studies that are available with the concrete structures. Couple of problems with the concrete structures is they might fall or concrete structures might fall all of a sudden. So they may not give any kind of indication. So you can see on the figure, once a person has started disturbing the concrete structures, it is going to get fail all of a sudden. So there is no indication that structure is going to get failed. So it's called as a brittle failure. That means without giving any kind of indication, the structure is going to get collapsed. So that's one of the problems with the concrete structure. So concrete is basically a brittle material. So brittle means it might fall down all of a sudden or it might break down all of a sudden without giving any kind of indication. So that's one problem with the concrete. And then the second problem is with it is prone to the attacks. Suppose if you see the World Trade Center, it has been attacked with the aeroplanes. So what happened when an aeroplane came and struck the building or the World Trade Center? So the entire structure has got collapsed all of a sudden. So you can see again the sudden collapse of the entire structure. So again here also we don't have any kind of indication for the failure of the concrete structure. So that's one of the problems with the concrete structures. And the other problem is we do have some problems with the concrete structure, such as suppose if you take the Leaning Tower of Pisa, so it is slightly bent. Okay, if you observe the Leaning Tower of Pisa, it is slightly bent to certain degrees. So what is the problem there? So actually talking there, the problem is not about the concrete material, it is about the foundation that is there for the concrete structure, for that particular structure. So the foundation was very weak along one side of the Leaning Tower of Pisa, and on the other side it was little better, or the bearing capacity of the soil was little better. And that's how the concrete structure has bent or has tilted to a little orientation or to a little degree of freedom. Now here, what is happening? So there are also certain problems with the concrete structures as well. So we cannot completely say that yes, concrete is completely a pure material where no problems will happen. Yes, there are some problems, but when you compare with the wood or with the steel, we have much better advantages for the concrete structures. So that's why we started using concrete structures and we started utilizing the concrete structures in the real time scenarios. So that's where we end up studying the or we end up finding out the reasons to identify or to understand the study of the concrete structure. So that's how we are going to look towards the concrete structure. Anyways, so I mean, besides talking about the disadvantages of the concrete structures, it is also important to understand why we are using the concrete structures on a large scale. So yes, we do have the disadvantages, as I was telling, but why we are going it on a large scale? What are the other couple of advantages that we have? So that advantages on a micro scale, we are going to look in this entire course. Okay, I cannot say that in this particular unit I'll be answering all your questions. So over a period of time, when we go deep dive into the different concepts in the concrete, we will be understanding, okay, maybe for this reason we are going towards concrete structures. Maybe for that reason we are going towards the concrete structures, right? So now, first let us understand what actually is a concrete. Suppose if you want to define a concrete, so we can define concrete as a homogeneous construction material. Homogeneous, I mean it can act as a single material. So what actually consists in this concrete? So concrete is not actually the material. So it is a combination of different materials. So that's when we call it as a concrete. So concrete is actually not a single material. It is basically a combination of multiple materials, and all those multiple materials will act as a single material. Okay, all those multiple materials will act as a single material, and that's why we are calling it as an homogeneous construction material. So basically, the concrete consists of four different materials. The first one is called as a cement. So we have different types of cement. So we'll be going towards that in the later cases. So concrete is a material which consists of a cement, which consists of the fine aggregate, and then which also consists of the coarse aggregate, and we have to use the water to mix all these materials. So roughly speaking, concrete is a material which consists of a cement, fine aggregate, which is called as a sand, coarse aggregate, which is called as a gravel, and water. So when you mix all these four materials together, so yes, we do have the admixtures, but I'm not going into the admixtures topic here. So when you mix all these four materials, we are going to get the concrete. Okay, we are going to get the concrete. So that concrete which we are going to get after mixing the water is called as a fresh concrete. So here the concrete is in the fresh state. So in whichever shape you are going to pour this fresh concrete, that will be the shape of the structure or the structural member. Now, once this concrete structure or once this fresh concrete gets hardened over a period of 28 days of curing or 14 days of curing, then we are going to get the hardened concrete structures. That is what we are seeing in the hardened concrete structure. Suppose if you are staying in a house, that is a hardened concrete structure. So before the concrete gets hardened into a particular form, initially it will be available in the form of a fresh concrete. So basically, we'll take the fresh concrete and we'll pour it into the molds of the concrete or the structural members of the concrete, and then we are going to get these kind of shapes. So that's how the concrete will turn from one stage to another stage. So the first stage of the concrete is called as the fresh concrete stage. And over a period of time, if this fresh concrete gets hardened, that concrete is called as an hardened concrete. So that concrete is called as hardened concrete. Now here, the cement and water. When you mix cement and water, they form a paste kind of material. So that is called as a cement paste. Now, in that cement paste, it can have the fine aggregate, it may not have the fine aggregate. But for time being, let us just consider that we have the combination of only cement with water, which is a cement paste. And this cement paste is something which makes a bond between the aggregate particles. Okay, the cement paste will make a bond between the aggregate particles. Suppose if you see here, are you able to see the concrete, I mean, aggregate particles inside the structure? No, we are not able to see the aggregate particles. Why? Because there is a proper bond that has got established between the fine aggregates and coarse aggregate with the addition of the cement paste. So when you have the cement paste, basically it creates a bond between the aggregates, and that paste will get hardened over a period of time. And that's where we'll get the hardened concrete structures. So that's how you can define the concrete structures. So concrete is basically a material or a homogeneous construction material which consists of a cement, fine aggregate, coarse aggregate, and the water constituents. So if you want to use the admixtures, yes, will use the admixtures, that is different types of admixtures, but my focus on admixtures will be completely in the upcoming classes, not in these particular classes. Fine. So now if you see the concrete, so I was telling that concrete is a mixture of the various materials. It is not a single material. So when you mix multiple materials such as cement, fine aggregate, coarse aggregate, water, and admixtures, we are going to get the concrete. Now here, it is important for us to understand if you take 100% as the volume of the concrete, okay, if you consider 100% as the volume of the concrete, so how much percentage of each materials will be there in the conventional concrete, not in special concretes, but in the regular concretes that we use. Suppose here, if you see, the coarse aggregate is the one which is occupying the largest proportion. It is almost taking the place of 45 to 50 percentage or 55 percentage of the entire concrete. So if you take the coarse aggregate, it might occupy up to 45 to 55 percentage. It can go beyond that also. But for consideration purpose in the conventional concrete, so coarse aggregate will take up to 40 to 50 percentage, and fine aggregate comes to the next place, which is this one. So it is occupying up to 30 percentage, and then cement is the thing which is occupying up to 15 percentage, and water is something which is occupying a better percentage than the cement, that is up to 20 percentage. And we do have certain quantity of air that is available in the concrete, which you can take it as up to 2 percentage, and admixtures we are going to use up to a dosage of 2 percentage. So this is how the combination of the concrete will consist of. So if we generally have to speak, so concrete consists of the major proportion as the aggregate, that is coarse aggregate. So coarse aggregate will take up to 50 percentage, and fine aggregate will occupy the next place, and then the next place goes to the water, and then the next place goes to the cement, and then the next place goes to the admixtures, and finally the air content. So that's how the entire concrete volume, that is, if we are considering 100% as the volume of the concrete, that's how we can define in a typical way of the construction or the concrete members or the structural concrete, you can say. Fine. So now let us understand one thing before we actually dive into the concepts of cement. So who is the father of civil engineering? So we might have the different answers for this question, but one of the most prominent or one of the most better answers for father of civil engineering is John Smeaton. So a person is called as John Smeaton. He will be called, or he is being called as the father of civil engineering. Now the question is why he is called as the father of civil engineering. So he had basically constructed a tower which is called as Eddystone Lighthouse Tower. So this is the tower which John Smeaton has got constructed. So upon the construction of this tower, he had been called as a father of civil engineering. Now, when this concrete structure or when this Eddystone Lighthouse Tower was constructed, so basically this lighthouse was constructed by using a material called limestone and pozzolana. So pozzolana is something and mineral admixture, you can say. So he had used the limestone and pozzolana to construct these structures. Again, this is not a cement structure. This is a structure which is purely made up of limestone and pozzolana. Okay, limestone and pozzolana. And this is actually constructed with a height of 72 feet tall, but this structure is no longer available. It has been collapsed maybe in the last 100 or 150 years back. So if I'm not wrong. But the thing here is why he is called as the father of civil engineering. Don't we have the structures before actually the Eddystone Lighthouse Tower? Yes, we do have the structures. We do have structures which are made up of other materials also. But why John Smeaton is called as the father of civil engineering? So the prime reason for that is before John Smeaton had actually constructed the structure, this particular structure, Earlier days, I mean, in the early days, the people who are responsible to construct the structures uh, are the soldiers, or you can say it as a navy people, or the soldiers also you can say. So soldiers are the people who used to construct, or the military people are the persons who used to construct all the structures that we had before the construction of this Eddystone Lighthouse Tower. Now, John Smitten is the first person who is not from the military background. Okay, John Smitten is the first person who is not from the military background, and he had constructed this structure, and that's where we called him as a civil person. Civil is the I mean, the meaning of civil is something like, so who is not belonging to the soldier category, or who is not belonging to the soldiers. So earlier we had the structures which are constructed by the soldiers. Okay, which are constructed by the soldiers. Now John Smitten is the first person who had constructed this tower, who is not from the soldier background, or who is not from the military background. So that is why he is called as the father of a civil engineering. Okay, that is why he is called as the father of civil engineering. So that's how we can answer this particular question. Who is the father of civil engineering is John Smitten, and he had constructed a structure by using the limestone and pozzolana, which is having a height of 72 feet tall. So in those days, it is one of the grandest structure we can call, because he is the first person who is not from military background, and he might not have any good idea about how to construct a structure. And in the very beginning days itself, he had constructed a circular structure. So it is not even a square or rectangular structure. It is a circular structure. But still the structure is safe for a period of time, at least for 50, 60 years, this was standing still. So there was no problem. So then over the next days or next years, it has got collapsed. So that's where we call John Smitten as the father of civil engineering. Now, let us understand the history of the concrete. I'll just show you one video. You can have a look into this video. So where it talks about how the concrete structures has got evoluted over a period of time. So you can see the video here. So yeah, so the video is playing. So you can see the video that has got started. Yeah, so that's how the concrete structures has got evaluated over a period of time. This is one of the videos by a concrete manufacturer, which is called as Pudlo, so which is, I think it is based from Germany and France. So they have made this detailed video about how the concrete structures has got initiated over a period of, from the very beginning days to the latest days that we started constructing the structures. So that's how this video is explaining about how the concrete structures has got developed over a period of time, right? So fine. So now let us understand the history of the cement. So now we have seen the history of the concrete structures. Before we jump into the concrete structures history, let us understand the cement history first. So here in the very early days, suppose if you take the Romans, the Egyptians, and then even Indians also, the very old age Indians. So we don't have the cement in that scenario. Okay, we don't have Egyptians, all the Egyptian pyramids or the Roman structures. We don't. They did not constructed the structures that Egyptian pyramids and then Roman constructions. They were not done by using the cement materials or the cement, but they have used a parallel material which has almost the same properties of the cement. So they used almost a parallel material which has almost the same properties of the cement. So that's where they have constructed the structures. Maybe we might not be able to access such kind of material in nowadays because of various reasons, but maybe they started constructing the structures by using certain kind of clay material, which is like sticky material and which can be bonding the materials that are used in the concrete members. And then the early Greeks and Romans have used a certain kind of cementing material by burning the limestone. So actually, this is where the limestone has actually come into picture, by which was constructed by using the Greeks and the Romans people. And then in India, we used a powdered brick, which is called as surki. Even nowadays, also we have this surki. So which is basically used in the mortar. So mortar is basically a mixture of cement, fine aggregate, and water. I'll just talk about that. And then the Romans had used a certain kind of blood. Again, this is not the human blood here I'm talking about. This is the blood which is obtained from the pig. So that pig blood will have the good cementitious properties. So that's where they have used certain kind of blood from animals, extracted from animals, and they have used the milk. And there is also a fat material which is called as lard. Again, this lard is also obtained from pigs and certain other material. These they have combined all these materials and they have got a cementing nature to the concrete members or to the members, the structural members, whatever they have constructed, and that's where the concrete structures has got evolved. And in the year 1824, Joseph Aspirin, a person called Joseph Aspirin, he had invented a material which is called as a cement. Again, it is not Joseph Aspirin is not a scientist. He is not somebody who is from the top background. Okay, he is not a scientist. He is not somebody who is working in a laboratory or something like that. He is just an ordinary person who is working in a site. So he was a labor in one of the sites. So he had invented or he had found out a material which consists of the cementing property. So upon finding out a material which consists of cementing property, that material he had he had found a material which is called as a Portland. So this Portland is a material which consists of certain kind of limestone which has the better cementing properties. That means which has a better glue properties to the material. So in the year 1824, on October 21st, Joseph Aspirin has took the patent for the Portland cement. Again, here Portland cement doesn't mean it's a type of cement. Portland is actually a stone that is having the cementitious properties. Okay, Portland is a stone that is having the cementitious property. And actually in India, Portland cement was first manufactured in the year 1904 by the South India Industry Limited cement plant. So this is how the cement has got come over a period of time, and then it has entered into India in the year 1904. Now you can imagine, so this is when we actually got the cement which is manufactured inside India. So earlier we used to get the import from other countries. Now, I mean, from the year 1904, we started constructing or we started manufacturing the cement, and then we started constructing the concrete structures or the cement structures. But the very first time the cement was invented was 1824, which was invented by Joseph Aspirin. Okay. Now, if you take any cement bag, okay, if you take any cement bag, you will be observing one common parameter on all the cement bags, which is called as a Portland. So you can see here, so Portland Pozzolana cement, ordinary Portland cement of grade 43, ordinary Portland cement of grade 53. Now here, one common name which we can observe is the Portland. Portland is the one common name. So as I was telling, Joseph Aspirin is the one who had coined this term called Portland. Okay, Joseph Aspirin is the one who had coined this term called Portland. So what is this Portland? Portland is actually a limestone. Okay, it has the properties of the limestone. So you can see Portland is actually one type of stone which has a certain kind of cementing properties, or which has the properties that consist of limestone. So it is a place. Portland is a place. I mean, Portland is a stone which is available in a place in UK. So there is a place called Dorset in UK. So in that place, we have the abundant material of Portland. Now I'm not. I mean, I'm not sure about whether we still have this Portland material over there or not. Over a period of time, maybe we have overutilized that material, and then there is no amount of material of Portland, if I'm not wrong. But however, we have been accompanying with that name itself, that is Portland cement, Portland cement. But actually, Portland is actually not a type of the cement, it is a type of the stone. It is a stone actually. Okay, Portland is actually a stone which consists of certain kind of cementing properties. Okay, this stone was identified first by Joseph Aspdin in a place called Dorset. So he was working as a laborer in this place called Dorset, and when he was digging down the material, or when he was digging some structure, so he found out this particular stone which has some cementing properties, and upon that property he had made that stone as a Portland stone. So upon that name, since then the cement was manufactured by using the stone called Portland, and hence we are calling it as a Portland cement, and that was coined by the term Joseph Aspdin. Now, the question is, can we call all the cements as the Portland cements? That's one question which we need to understand. So when can we call any cement as a Portland cement? So for that, we have a condition, which is any cement which does not have more than 5% of the inorganic materials. Okay, any cement which does not have more than 5% of the inorganic materials, such kind of cement is called as a Portland cement. So if a cement property, or if the cement consists of more than 5% of the inorganic materials, such kind of cement is not called as a Portland cement. So this is the condition that we need to remember in order to call any cement as a Portland cement. I hope it is clear. In order to call any cement as a Portland cement, we need to have less than 5% of the inorganic materials. Okay, fine. So that's how we are going to start with the Portland cement. Now, let us understand the different forms of the cement. So basically, the cement is available in the form of a powder, and
Excuse me,
then
sir.
when you mix, yeah,
Sorry.
yeah,
Sir,
yeah, please.
you said 43 grade and 53 grade. So
Yes,
why they given that 43 and 53 grades only?
yes. We'll be talking about that. When I talk
Ah,
types of cements, I'll be talking about that. We are
okay,
just jumped into the cement topic. That's it.
okay, sir.
Yeah, yeah, fine. So cement is basically available in the form of a powder, and then when you mix cement with water, okay, when you mix cement with water, it is called as a cement paste. So usually cement paste will be available in this form. So when you mix a cement, water, and the fine aggregate, it is called as a mortar. So cement paste basically consists of cement and water. That means when you mix a cement, water with the fine aggregate, it is called as a mortar. Okay, it is called as a mortar. This is how the mortar will be visible. When you mix mortar with the coarse aggregate, okay, when you mix mortar with the coarse aggregate, it is called as a concrete. Okay, so basically mortar consists of what? Cement paste and fine aggregate. What does cement paste consist of? It consists of cement and water. So therefore, logically speaking, concrete is a material which consists of a cement, fine aggregate, coarse aggregate, and water. So when you mix all these four materials, then you're going to get a material which is called as a concrete. So that's how the cement has changed its form from one stage to another stage. So logically speaking, cement is generally available in the form of powder. That's where we get the cement bags. So whenever a cement comes in contact with the water, that material we are going to call it as a cement paste. When the cement paste is mixed with the fine aggregate, it is called as a mortar. When the mortar is mixed with the coarse aggregate, it is then called as the concrete. That's how the cement is changing its form from one stage to another stage based upon the addition of the new materials. Now, in any concrete, we have basically two groups. One is called as an active group, and the second one is called as an inactive group. So what are these active and inactive groups? Active group is something which plays a vital role in determining the bond between the cement materials, or bond between the materials that are available in the concrete. So active matrix or the active group is a group which plays an important role in creating the bond or in establishing the bond between the concrete materials. And inactive group or inactive matrix is a group which does not play any role in creating the bond, but it plays a role in creating the strength to the concrete. Okay, active group majorly talks about the creation of the bond between the concrete particles, and inactive group majorly talks about the creation or the having the strength to the concrete. Let me show you that. So active group is a group which basically consists of cement and water. I was telling, when you mix cement and water, we are going to get the cement paste. So when you have the cement paste, obviously it is the main function of the cement paste is to create a bond between the particles. Suppose if you, let's say you have two bricks. So when you have two bricks, if you want to combine or if you want to make those two bricks as a single material, you will make the cement paste between the two bricks. So what actually the role of cement paste is there? So the cement paste will stick those two bricks. So that is called as an active group. And whereas inactive group consists of the aggregate particles, both the fine aggregate and coarse aggregate. Why we are using the coarse aggregates and fine aggregates? Why we are using the stones in the concrete to obtain the strength to the concrete? So in order to get the strength to the concrete, we have to go with the utilization of a fine aggregate and a coarse aggregate. So since fine aggregate and coarse aggregate will not play any role in the creation of the bond, the major role of a fine and coarse aggregate comes with the increasing in the strength to the concrete. That is why they are called as an inactive group. Here, cement and water will act continuously throughout the concrete structure. Fine aggregate and coarse aggregate will not act. Their only responsibility is to indicate or is to give sufficient strength to the concrete. And that's why we called it as inactive group. And that's where we called cement and water as an active group. Okay, fine. Before we talk about the cement properties or the manufacturing process of the cement, let us see some statistics that are available across the globe. So if you see certain statistics, so cement production every year around the world will be around approximately 2.8 billion tons. So this was the data that is from 2020. Now it might have increased to 3 billion tons probably. So anyways, you can get this value from the cement statistics website. So cement production every year across the world, we are producing 2.8 billion tons of cement every year across the world. And here, China is the largest producer of the cement, followed by India. So India is the second largest producer of cement. So the reason why only these two countries are the largest producers is we have huge quantities of the limestone that is naturally available. In the other countries, there are no sufficient amount of limestone deposits. They do have, but they don't have the quantities of the limestone deposits as much as we have in India and China. So again, even in India and China also, we started over-utilizing those limestone deposits, and then we started moving to different types of structures where we are replacing the cement. Anyways, so China is the largest producer and India is the second largest producer of the cement. And when you come in terms of the cement, the production which happens or the cement production that happens in India is almost 260 million tons. So we have this much quantity of cement that are going to get produced every year. So we are producing 260 million tons of cement. That is what the production capacity that is available. But what we can produce is we can produce up to 300 million tons. But currently we have the capacity to produce only 260 million tons, but we have the ability to produce up to 300 million tons. Maybe again, this value might have got increased to 265 or 270 million tons. Again, these are just for statistics, and we know that statistics will change every day. So they are not a constant values. Okay. And then the problem with the cement production is something which we need to focus on. So that is the carbon dioxide emissions. So basically, when we produce a cement, the carbon dioxide will get emitted into the atmosphere. And we know when carbon dioxide gets emitted into the atmosphere, we have the problem with the greenhouse gases and the ozone layer depletion. All these problems will come when we talk in terms of environmental aspects. But again, it is also very much important for the cement scientists or the cement industries or the cement manufacturing industries to take care of these carbon dioxide emissions. So we don't want carbon dioxide completely in the atmosphere, right? So to take care of the carbon dioxide emissions, yes, we do have certain materials, certain alternative materials, but due to the production of cement, okay, due to the production of cement, the amount of carbon dioxide that is releasing into the atmosphere is almost 7 to 8%. So just by producing the cement or just by manufacturing the cement, we are releasing 7 to 8% of carbon dioxide into the atmosphere. Again, this is a global value, not the value that is limited to India. But anyways, 7 to 8% is the very big value. It is not a small value. It's a very big on a large scale.
Is
Okay.
it per,
So 7
per
to,
annum, sir, is?
yeah, per annum. Yes.
Okay.
Yeah. So 7 to 8% of carbon dioxide will get released into the atmosphere because of the production of the cement. Now the question is how carbon dioxide is getting emitted. So we are producing cement, but how the carbon dioxide is emitting into the atmosphere. To understand how the carbon dioxide is releasing or how the carbon dioxide is getting produced while we are manufacturing the cement, we need to understand the raw materials first. So basically, to produce a cement, the primary raw material which we use is the limestone. Okay, that is called as calcium carbonate. So the chemical formula of calcium carbonate is CaCO3. This is the limestone, which is a calcium carbonate. Now, what happens here is we are going to burn this calcium carbonate. Okay, we are going to burn this calcium carbonate. Now, when we burn this calcium carbonate, the reaction that goes in this way, you can see here. So here I'm going to burn the calcium carbonate, and when I'm going to burn the calcium carbonate, I'm going to get two materials. One is called as a CaO, which is calcium oxide, and the second one is called as a CO2, which is carbon dioxide. So that's how the carbon dioxide is emitting into the atmosphere. So when you burn the calcium carbonate, it is releasing two kinds of materials. One is called as calcium oxide, and the second one is called as carbon dioxide. So because of this burning of the limestone, we are going to get the carbon dioxide emissions into the atmosphere. Anyways, we'll have a detailed talk about this particular equation in the upcoming classes. But for time being, just understand that. So the cement production indicates almost 7 to 8% of the carbon dioxide emissions. So how this carbon dioxide emission is taking place? Because of the burning of the calcium carbonate. So when you burn calcium carbonate, we'll get two kinds of materials or two kinds of byproducts. One is called as calcium oxide and the second one is carbon dioxide. Fine. So here, couple of things which we need to focus on. 1 ton of calcium carbonate produces almost 400 kilograms of carbon dioxide. So if you burn 1 ton of calcium carbonate, that means limestone, if you burn 1 ton of limestone, it produces 400 kilograms of carbon dioxide. That means we are using only 600 kilograms of calcium carbonate. The rest of the 400 kilograms of calcium carbonate is getting converted into the form of carbon dioxide. That's how calcium carbonate is responsible for the release of the carbon dioxide. And there is also one more statistic which is called as 1 ton of clinker, which is a hardened form of the cement production. So it is one of the hardened stages of the cement production. I'll show you the image of this one in some time. So 1 ton of clinker is able to produce almost 1 ton of carbon dioxide. So you can see here by this figure itself, it is very clear that we are producing huge amounts of carbon dioxide, or we are responsible for the release of huge amounts of carbon dioxide into the atmosphere. Anyways, I'll show you the image of the clinker and couple of other things, how the carbon dioxide gets evaluated based on this particular equation. So these are the couple of statistics that we need to understand when we need to know about the cement production process or the manufacturing process, what actually happens, how we are harming the environment, what are the alternative ways. So people are working towards this alternative way. Can we reduce the carbon dioxide emissions in the production of the cement? So there are many studies that are going on. So you can have a reference to the papers that are available. So fine. So now let us talk about the manufacturing process of cement. So basically, in order to manufacture the cement, we have two process. One is called as the dry process, and the second one is called as a wet process. So these are the two process of manufacturing the cement: dry process and wet process. And we also have the third one, which is called as a semi-dry process. Anyways, I'll talk in detail about all those processes in some time, but let me just show you on a plain level how the cement manufacturing will take place. So basically, the raw materials which are used for the manufacture of cement are broadly categorized into two ways. The first raw material is called as calcareous material, and the second raw material is called as argillaceous material. Okay, so calcareous materials basically consist of the limestone and chalk, which are basically rich in the calcium carbonate mineral. Okay, calcareous materials majorly consist of a mineral called calcium carbonate, and this calcium carbonate is majorly available in limestone and chalk. So basically the chalk pieces which we have, it also consists of the calcium carbonate. So those materials are called as calcareous materials. And argillaceous materials are the materials which are having good amounts of clay particles or good amounts of clay minerals. So the good amount of clay minerals basically consist in clay and shale. So the raw materials that are required to manufacture the cement are broadly categorized into two ways. One is called as the calcareous materials, which consist of limestone and chalk, and the second one is called as argillaceous materials, which consist of clay and shale. Now, if you ask me again, do we have only these four materials, or do we use only these four materials to manufacture the cement? No, we have other materials also, but majorly these are the classifications: calcareous materials, which are rich in calcium carbonate mineral; argillaceous materials, which are rich in clay minerals, right? So these are the other sources of different minerals. You can see the calcium is majorly available in limestone, shale, and marl materials or marl minerals. And silica is something which is majorly available in sand, clay, shale, and marl. And alumina is something which is available in clay, shale, and slag. And ferrous oxide is something which is available in iron ore, clay, and mill scale. Now, again, we need to understand very deep about what is the role of calcium in the cement, what is the role of silica in the cement, what is the role of alumina in the cement, and what is the role of iron oxide in the cement. That we'll see over a period of time. But for time being, to understand the different sources of various materials, so we need to have the calcium, silica, alumina, and iron oxide. These are the four major raw materials that we use in the manufacturing process of cement: calcium, silica, alumina, and ferrous oxide. So where will we get the calcium content? These are the sources of getting the calcium. So these are the sources of getting the silica content. These are the different sources for alumina content, and these are the sources for iron oxide content. So that's how the different sources of the raw materials are there. Again, we'll need to go and understand in a large scale. I'll be talking about the role of all these four materials in some time, right? Fine. Let us understand the different stages of cement manufacturing. So if we have to broadly speak, there are three different stages of cement manufacturing. The first one is called as grinding. So what we actually do in this process is, whatever the raw materials that we get, all those raw materials will be grinded into a fine powder. Suppose, let's say you have got the limestone from the limestone quarries. Now, do we have this limestone which is available in the form of powder? No, we don't have this limestone in the form of powder. So we'll get huge stones or huge boulders we'll get in the form of limestone. Now we need to grind those boulders, or we need to crush those boulders, or we need to crush those stones. Then we are going to get the raw material. And that process, the very first process of grinding, involves the grinding of the raw materials. That means breaking down huge rocks into a small parts or a powder form. That's the first stage of cement manufacturing, which is called as grinding. And the second stage is called as burning. So once we grind all these materials, we are going to burn the material. Okay, we are going to burn the materials. And here, when we are burning the materials, we'll use certain materials, I mean, certain apparatus or certain equipments to burn this material, which is called as furnace. Okay, and we are going to burn the cement materials at a temperature of 1300 to 1500 degrees centigrade. And then after burning and after doing certain stages in the burning process, we are going to do the cooling process. So here we are burning the materials at 1300 degrees centigrade, which is very high. So the next immediate process is we are going to cool the materials. And after the material is cooled down, we are going to add gypsum in the concrete. We are going to add gypsum in the cement. So what is the role of gypsum? That we'll see in some time. But gypsum we are going to add at a dosage of 3 to 5% in the cement. So when you take a cement bag, So in that cement bag, we'll have at least 3 to 5% of gypsum will be there in the cement bag. And the final product, whatever we are going to get, that is called as a Portland cement. Okay, the final product is called as the Portland cement. That's how the different stages of the cement manufacturing involved: grinding, burning, and cooling. So in the grinding, we are going to grind all the raw materials. In the burning, we are going to burn the raw materials, and then we are going to cool the materials, and finally we'll add gypsum in the cement, and then finally we are going to get a material which is called a Portland cement. It is something like, suppose if you want to make a chapati or if you want to make a roti, so what is the first thing that you do? You will get the, I mean, first the farmer has to grow the wheat or jowar, whatever it is. So then all the wheat has to be extracted from the crop, and they have to grind it. That means whatever the top layer that is there on the wheat, they have to remove the top layer. That process, you can call it as a grinding. So then once after the top layer of the wheat materials are removed, they are going to send it to the crushers, where we'll get the powder, or where we'll get the atta. You can call it as atta powder or the chapati powder, you can say. So once we get the atta powder, we are going to burn it. So if you want to make the chapati, you have to heat it. You have to add some water and then you have to heat it. So then you are going to burn it. So once we are going to burn the chapati, can we eat the burnt chapati? No. So we have to cool it further. So after cooling, can we eat the raw chapati or the raw roti? So we need to have certain additions for that. Maybe we need to have the dal, or maybe we need to have other kind of materials to eat chapati. So that other material is here is gypsum, and then we can finally eat the atta. And then we can finally eat the roti or chapati. So that's where you can have a cross parallel world in the process of manufacturing of cement: grinding, burning, and cooling. So these are the three different stages. But again, we need to understand this on a large scale. So here, if you see the production of the cement, so this figure explains in a very better way. So yeah, so this figure explains it in a very better way. First, we are going to get the raw materials from the quarries. You can see the limestone quarry, the number one. So the excavator will be there, where the huge JCBs will be there. They are going to extract all the raw materials that are required, and once the raw materials are extracted, they are going to send it to the dump trucks. Okay, they are going to fill it in the dump trucks, and then they are going to send it to the manufacturing ad. And in the manufacturing ad, they are going to crush all the raw materials into the fine powders. You can see this is the very first stage of obtaining the limestones, and then they are sent to the crushers. Once they are sent to the crushers, some size of the limestones has got decreased, and then they are finally going to send it to one more crusher, which is called as a secondary crusher, and then you will get the very fine particles of the limestone. And then this limestone, they are going to send it to the different portions where they are going to store it. Okay, here you can see the sand that is getting stored, and here the clay is getting stored, and then they are going to mix all these materials. That is called as a grinding mill. So once they mix all the materials, they are going to send through different chambers, where if there are any amount of moisture, if there is any amount of moisture or any inorganic matter, by using this heater tower or the preheater tower, all that moisture will get evaporated. So once the moisture gets evaporated in the preheater tower, then they are going to burn it. So I was telling that in order to burn, you need to have a temperature of 1300 to 1500 degrees centigrade. So that burning we'll be doing in an equipment which is called as a kiln, KILN. That is also called as a rotary kiln. So once you burn all the raw materials, you're going to get a material which is called as a clinker. So you're going to get a material which is called as a clinker. And then this clinker will again be cooled, because the clinker is available in the very like 1300 degrees centigrade temperature, which is very high. So we need to cool it. And after cooling the clinker, what we are going to do is we are going to add some gypsum into the clinker. And after adding gypsum, we are going to send the clinker. Basically, the clinker is available in the form of small stones. Okay, that is not a powder, that is available in the form of small stones. Here, the clinker along with gypsum, we are going to send it into a ball mill. So we are going to send it to a ball mill. So what actually happens in the ball mill is we are going to rotate. It's like the grinding machine. Suppose if you have the mixer, if you keep any kind of pieces into the mixer, what that mixer does, it will grind that entire material into a powder form. So this is where actually the powder form of the clinker will get converted. So this is where we'll get the cement. Final product, we are going to get the cement. And then we are going to store it in the silos, SILOS, and then we are going to dispatch it to the places wherever that is required. So that's in a simple way how actually the production of cement will take place. But let me also show you the each and every stage in the real-time scenarios. This is something which we have imagined it and we have got this picture. But let's see whether all these stages are available in the real-time scenario or not. So let's have the industry, the cement industry glimpse. So this is something which are available from the real-time scenarios. So what is the first thing? First stage is we are going to extract the raw materials from the quarries. So limestone, the whatever the raw materials that are required, that is calcareous materials and argillaceous materials. So all those raw materials will be extracted from the quarries, and then they are going to store it in the cement industries. So that's called as storing of the raw materials. You can see all the raw materials are being stored. Okay, so this is the crusher, you can say. So all the raw materials are getting stored. You can see the some amount of raw materials are coming out of the crusher because the function of the crusher is to crush the raw materials into a small stones, right? So then what we have is we are going to get the small pieces of the stones. Okay, maybe the limestone or any other materials. It need not be only limestone. So then all these raw materials, which are in the form of small stones, will be sent through a conveyor belt. Actually, this is a conveyor belt. You can see a small rollers beneath the belt. So it is actually a conveyor belt. It's like something, suppose when we go to airports or railway station, we'll send the bags into a chamber where the bags will be tested for any materials. Similarly, that convey on the conveyor belt, we are going to send all the raw materials. And then after sending, where we are going to send these materials? So we are going to send all these materials into the chambers, the different chambers. So wherever these materials has to be stored. Now we cannot store all the materials in a single chamber. So we need to have different chambers to store the materials. That is where it is happening. You can see the chamber 1, chamber 2, and multiple chambers that we have in the back end also. Okay, and then once the materials are stored, so these are called as the chambers, these are called as silos, SILOS. So we'll store all the raw materials in the silos, and then what we are going to do is once the raw materials are stored in the silos, we are going to heat the raw materials. Okay, we are going to heat the raw material. This is basically a heat chamber. Okay, we are going to heat the raw materials. So once the heating of raw materials happens, this place is called as the rotary kiln. So this looks very small in the picture, but it will be very huge. It's as huge as more than 10 meters diameter will be there for this particular chamber. So this is called as a rotary kiln. So what happens with the rotary kiln? So in the rotary kiln, we are going to burn all the materials. Okay, in the rotary kiln, we are going to burn all the materials. So once we burn all the materials, we are going to get the heated material. But how will we do? Are we going to send the materials into the rotary kiln based on manual process? Are there any labor who will be sending? Can you see some amount of labor? There are 3 to 4 labors that are available in this particular location. But what is the function of these labors? Are they going to manually dump the materials into the rotary kiln? No, they are not going to do that. So that entire process is an automation process. So we'll have a software for that in the cement industries, and then based on the softwares, they are going to decide how much amount of materials they are going to send into the rotary kiln. So this is all an automated process, computer automated process. And then once the materials are completely burnt, we are going to get the clinkers. Can you see a small stones that are available? These stones are called as clinkers. And you can see the red color also because they are completely burnt material. So they are having they are burnt at 1300 degrees centigrade, 1300 to 1500 degrees centigrade. That means they will be very hot. So once we get the clinker, which are completely burnt, we are going to cool the clinkers. Okay, we are going to cool the clinkers. So all these clinkers are again sent into a cooling chamber. Okay, all these clinkers will be sent into a cooling chamber. Once the clinker is cooled, okay, once the clinker is cooled, what we will do is we are going to get the clinker material, that means cooled clinker materials. And here we are going to add some gypsum to the clinker. Okay, we are going to add 2 to 5% of the gypsum based on the quality of the cement that we are producing. So once we add gypsum to the clinker, these stones, basically clinkers are small stones. So we need to grind these clinkers. So in order to grind these clinkers, we are going to send it into a next stage, which is called as a ball mill. Okay, this is called as a ball mill, Ballmill, the ball mill. So what actually consists of this ball mill? So inside this ball mill, we have the very solid steel balls. You can see steel balls are available. So these are actually the steel balls. What actually happens inside this ball mill is this ball mill will rotate. Okay, this ball mill will rotate. Now, when this ball mill is getting rotated, because of these steel balls, all the clinkers will get converted into the form of a powder. Okay, will get converted into the form of powder. And then finally, we are going to get the cement. And if you want, we are going to store the cement. And once the cement is stored, we are going to transport it. We are going to package them and we are going to transport it to the places wherever that is required. So this is how the cement will get manufactured in the cement industry. That's how it happens in the real-time scenarios. I hope it is clear. Now, how actually the cement industry will work and what are the different stages of the cement manufacturing in the real-time scenarios. Right? So now let us understand the process of manufacturing the cement. So as I was telling, we have two different processes of manufacturing. One is called as the dry process and the second one is called as the wet process. And we also have the third one, which is called as a semi-dry process. But again, I'll just show it on a plain scale for time being. So let us understand that. So wet process, dry process, and semi-dry process. So let me show you one video which talks about how the cement will get manufactured. You can see here. So the raw materials are getting obtained from the quarries. Yeah, so that's the entire process of cement manufacturing process. Again, it is obtained from the direct YouTube. The source is YouTube, which is from the AfriSam cement producers. I think they are from some other country. I don't remember that country name. Anyways, so they have explained it in a very better way with the video format. Fine. So let's understand the flow chart of the cement manufacturing process. Initially, we'll get the limestones. That means we are going to quarry wherever the limestone deposits are available. So we'll get the limestone from the quarries, that is called as limestone quarrying. And then once we get the limestone, we are going to crush the limestone into small pieces. And then we are going to grind the limestone into the form of a powder or almost a small stones, you can say. And once we grind the raw materials, we are going to heat the raw materials. The process of heating basically involves is a dry process. So why we are going to heat the raw materials? Basically, when we get the raw material, certain raw materials will have certain amount of moisture inside it. There will be certain amount of vapor inside it, or water vapor, or the moisture will be available. So we don't want the moisture to be available for the manufacturing process of cement. So in order to make the materials into a completely a dry state, we are going to heat the raw materials. That process is called as a dry process. So in the dry process, we are going to heat all the raw materials. And then we also have one more process, which is called as a wet process. So in the wet process, what we do is whatever the materials that we get here, that materials may or may not contain moisture. Let us assume that the materials may or may not have moisture. So if the materials are having moisture, that doesn't make a problem. If the materials are not having a moisture, that again doesn't make any problem. So what we do in the wet process is we are going to add water to all these materials. Okay, we are going to add all these water in the to the all materials. So when we add water for the materials, that process is called as wet process. When we remove the moisture that is already available in the material, that process is called as a dry process. So by using these two processes, we are going to manufacture. But again, so which process that we are going to use and why we are going to use only that process, that we'll see in some time. I'll explain it very clearly about what actually the stages that are involved in the dry process of manufacturing of cement and what are the stages that are involved in the wet process of manufacturing of cement. Fine. So now we are going to heat the raw materials in the dry process. We are going to wet the raw materials in the wet process. So once this is done, we are going to send it to the rotary kiln. Okay, what is the function of rotary kiln? We are going to send it to the rotary kiln where we are going to produce a certain amount of heat to the materials. Okay, we are going to heat the raw materials at a temperature of 1300 to 1500 degrees centigrade. So once the raw materials are heated in the rotary kiln, we are going to immediately cool the raw materials. So once the raw materials are cooled, we are going to add certain amount of gypsum to the clinker. Okay, we'll get the clinker from this one, and then we are going to add gypsum here. And along with the gypsum and the clinker, we are going to grind it in a ball mill. Okay, we are going to grind it in a ball mill. That is called as cement grinding. So then we'll get the final product, which is called as the cement. So if we want, we'll store the cement. Otherwise, we'll dispatch the cement by packaging to the cement manufacturers or the cement requirement places. So this is in simple about the process of manufacturing of the cement. Again, we need to understand these two processes in a deeper way. So let me talk about that process. But before I talk about the dry process and wet process of manufacturing of the cement, let us understand where is the feasible location or what is the feasible location for the cement industries to start. So suppose, let's say you want to start a cement industry or you want to establish a cement industry. Can you establish the place? Can you establish wherever you want? No, you cannot establish in that way. So what is the feasible location for cement industries establishment? Wherever you find huge amounts of limestone, okay, wherever you find huge amounts of limestone, near to that area, you can establish the cement industries. So if you take any cement industry across the globe, all these cement industries will be established near to the limestone quarries only. So wherever they have the limestone quarries, maybe in that region or in that location or in that district, they are going to establish the cement manufacturing industries. That's one thing which we have to remember when you want to start a cement industry or a cement manufacturing industry. It should be the place where we get huge amounts of limestone. That is what abundant availability of limestone quarries. That's one of the feasible location. And here the second thing is, does the strength or development of cement or concrete is affected by two cement manufacturers located in two different regions? So to understand this question, let me take one sample thing here. So what I would like to tell is, suppose let's say we have the Ultratech cement. Okay, we have the Ultratech cement. Let me make it as ULT, Ultratech cement. Now, Ultratech cement, do we have the Ultratech cement manufacturing company only in the one particular state? Let's say we are taking some Telangana state. Let's assume that we are taking some Hyderabad, Telangana only. Let's consider Telangana state. Now, if you take in Telangana, okay, instead of taking it as Telangana state, let me take it as Andhra, because in Andhra we have better deposits. So let me talk about this one. So I have the Ultratech cement, okay, and this Ultratech cement has established the cement industries in the Andhra Pradesh, okay, in the Andhra Pradesh. Now, do we have the Ultratech cement only in one particular district of Andhra Pradesh? No, we don't have. So we have in multiple districts. Suppose if you take the multiple districts, Anantapur is one place where we have the cement manufacturing unit, and then Kadapa is also one of the place where we have the cement manufacturing unit. Likewise, we have multiple places where this Ultratech cement is available. I mean, not just Ultratech, any cement factory for that matter. Okay, in Andhra, I mean, in near to Anantapur and Kadapa, I think I mean, we have this thing called L&T cement, if I'm not wrong. Even I don't remember it exactly, but for time being, let us just consider it as an Ultratech cement. Now, if you compare here, so the distance between these two places, let's assume the distance between Anantapur and Kadapa is almost 200 kilometers. Let us just, for figure I'm telling, so let me just consider the distance between Anantapur and Kadapa regions are 200 kilometers. Now, whatever the raw materials that are available in the Anantapur district may not be having the same quality of the raw materials that are obtaining in Kadapa district. So what is having here? So the problem is the raw materials which are available in the Anantapur district may not be having the same quality as they are available in the Kadapa district, right? As they are having in the Kadapa district. But the entire cement is the same. The brand of the cement is same, but the quality of the materials gets changed here. Okay, the brand of the cement is same, but the quality of the cement materials or the cement production materials is different. So the question here is, does the strength development of cement is affected by two cement manufacturers or two same cement manufacturers? That means same cement manufacturer. Ultratech is the same cement manufacturer, but located in two different regions. So Ultratech is available in Anantapur district and it is also available in Kadapa district. So what the question is, so whatever the cement that is available from the Anantapur district, will it have the same strength as when we compare with the Kadapa district cement? Obviously, yes, there will be a change. Okay, the strength development of will vary based on two cement uh, locations based on the properties. Yes, they do get varied. Okay, that's the answer. Yes. So there is a change. Obviously, there will be a change because they cannot transport the materials from Anantapur district. Suppose, let's say, in Anantapur district, we'll have the better quality of the materials. So you cannot transport all these materials to different places, right? It's not possible scenario. So that's the case. Even though the cement manufacturer is same, based upon the location of that plant, the quality of the cement might get affected. Okay, might get affected. Again, that may not get affected at a large scale, but yes, they do get affected. Okay, they do get affected. So how they get affected based upon the quality of the materials, based upon the operations that we are performing in the kiln, based upon the different composition of the materials. So all these parameters will have the influence on strength property, which is coming from the same manufacturer but different location. So I was talking about this one only. So Tadipatri is one place which is available in Anantapur district. Alone in Tadipatri, it has almost 6 cement factories. Okay, alone in Tadipatri region, it has 6 cement factories. Why they have the 6 cement factories established? Because Tadipatri is some place which has huge amounts of limestone deposits. And there is also one more place in Tamil Nadu, which is called as Ariyalur. So in this place, they also have the cement manufacturers. And again, in these two locations, the cement producer is same. I think it is Ultratech only, if I'm not wrong. So cement producer is same, but the quality of cement that you are going to get from the Tadipatri will not be the same quality as you are going to get in the Ariyalur. So it is considered that in the Tadipatri region, so the limestone will have the better properties, or the better properties will be there for the limestone than when we compare with the Ariyalur. So that's where the justification comes for this question. Yes, the cement, though the manufacturer of the cement is the same, based upon the location of the manufacturing plant, the properties of the cement will get changed. Why? Because the properties of the materials, the raw materials are getting changed. So when the raw material property itself is getting changed, obviously the quality will get changed. See, suppose we have different oil products. Suppose, let's say we have the coconut oil, we have the groundnut oil. So let's say we have the groundnut oil. So groundnut oil will be manufactured by different companies, right? We have the many companies who manufactures the cooking oil. Now, even if they are coming from the same location, I mean, same brand, the quality gets changed. Similarly here also. Okay. Now, where actually the best sand is available? Suppose we are talking about the concrete. So we have the fine aggregate in the concrete. So where actually the best fine aggregate is available in the India? I'm talking in terms of India. So there is a place which is called as Ennur. So that is available near to Chennai. So that sand is also called as an Ennur sand. Okay, that sand is also called as Ennur sand. It is said that this is one of the finest quality of the sand that is available. Again, so people are not being allowed to extract the fine aggregate from this place because that place has got, I mean, when the excavations are getting too high, that place is having certain kind of downfall. It is going below the sea level. So when any city goes below the sea level, obviously when heavy rains comes, that city will get submerged. So because of that reason, so we are not using any kind of river sand now. We are using a sand which is called as M sand or manufactured sand. So that is actually the crushed stone sand. Again, that we'll talk in the second unit. We'll focus on aggregate part in the second unit. But the question, something which you might be asked by a common people is where the best sand is available. So this is the place. Ennur is the place which is available in Chennai where we get the quality of the quality fine aggregate. Okay, only the fine aggregate, not the coarse aggregate. And that sand is also called on the same name, which is called as Ennur sand. Okay, fine. And as we know, the typical cost of cement bag, again, this is the statistic which I got it from maybe 2020, 2021, somewhere between that. Now it might got changed to almost 450, close to 450 it is there, if I'm not wrong, 450 or 470 it is there. In Tamil Nadu, I think it is like 470 something. In Andhra and Telangana, it is also somewhere around 450 to 480, if I'm not wrong. Again, as I said, this is a statistic can change at any point of time. Fine. These are a couple of things that we need to understand. And then if we talk about the dry process of manufacturing of cement, so what we use in the dry process is, so in the dry process, we are going to heat the raw materials. That's the only thing that we need to remember. So in the dry process, we are going to heat the raw materials. Why we are heating the raw materials? If there is any kind of moisture that is available in the manufacturing process, that moisture should not be there. So complete manufacturing of cement by dry process is basically done by when the raw materials are completely dry. Okay, they should not have any kind of moisture is involved here. But whereas in the wet process, we will add water in the materials. You can see here. So if you compare this one, so here we are not having any kind of water. Okay, in this process, in the dry process. But whereas in the wet process, we are intentionally adding water to the raw material. Why we are adding the raw materials? If there is any kind of inorganic matter, we are going to clean that inorganic matter that is available in the raw materials. So intentionally we are going to add. Okay, here we are going to get a slurry. So when we add when we add water to the raw materials, we'll get a thing which is called as slurry. Slurry means it's a kind of water. Okay, slurry tank you can see here. Then once we cool or once we clean the raw materials by using water, we then send those raw materials into the rotary kiln where the temperature will be there. Okay, 1300 to 1400 degrees centigrade. Again, the process remains same. The only difference between the dry process and wet process is in dry process, we don't clean the raw materials, but whereas in the wet process, we intentionally clean the raw materials by the addition of water, and then we follow the similar process. And that's the difference. But the question comes, which method we can use? Is it the wet process or the dry process? Suppose if you talk about the both process, or if you compare the both process, for many years, the wet process remained popular. Okay, because of the possibility of more accurate control in the mixing of raw materials. But for the past couple of years or couple of decades, you can say, not years, couple of decades, we started employing the dry process only. Okay, the dry process gained momentum with the past couple of decades, and then we started using the dry process. Why we started using the dry process? Because when you want to manufacture the cement in the wet process, what actually happens is you need to have additional amount of water. So when you need additional amount of water, that's something which is a natural resource. So when you are using the water to clean the materials, you are utilizing the natural resource. So that's something which is a problem to the natural environment. So that's where we started moving to the dry process. And there is also one more problem with the wet process. Suppose in the dry process, we are going to use a temperature of 1300 to 1400 degrees centigrade. As we know, in the dry process, we have the dry material. All the materials are in the dry state. But whereas in the wet process, the materials are in the wet state. That means you need to have huge amounts of heat to dry these wet materials. Okay, so when the materials are dry, you just need 1300 to 1500 degrees centigrade. But when the materials are wet, you need much better temperatures to dry those materials. So that's also one of the problems. So in the dry process, you need to have less amount of fuel consumption is required because the materials are already in the dry state. But whereas in the wet process, the materials are not in the dry state, you need to have high amounts of fuel. That's something. So you can see here, the power consumption by the dry process will be little less when you compare with the wet process. So in wet process, in dry process, you can see 3000 kilojoules per kg of power is required. But whereas in the wet process, it is almost double the times of power that is getting consumed, almost 5000 kilojoules per kg. So that's also one of the reasons why we started shifting towards the dry process. And in the wet process, the kiln length will be more in the wet process, but whereas in the dry process, the kiln length will be very less when we compare again. So recently, a number of cement manufacturers have been commissioned to employ the dry process method only. So there have been a government order which is issued by the central government. Not recently, again, it's a couple of decades back. So we started using employing only the manufacturing of cement by the dry process, not by wet process. That's the simple difference between the dry process and wet process. So nowadays, all the cement manufacturers are using the dry process to manufacture the cement, not the wet process. So that's something which we can compare with the Aspidin clinker, that is Joseph Aspidin clinker, and then the modern clinker. So if you have the comparison here, the relative burning rate is very slow. In the very early days, obviously we cannot define the properties of the material. So when Joseph Aspidin first found the cement and he manufactured the cement, the burning rate was relatively slow. But whereas in the modern clinker, obviously with the technology enhancements, with the development in the manufacturing process, we have the better manufacturing rates. And you can see the A light, B light size. A light and B lights are some components. So you can see the size of the cement particles has got increased in one case and it has got decreased in the other case. And the cooling rate is also very slow in the Aspidin clinker process. Again, with the technology enhancements, we got better faster cooling rate of the clinker, and then C2S, the kiln behavior, all these things we can compare. Okay, fine. So that's about the brief introduction towards cement, and this is something which is a microscopic image of the cement. Okay, if I have taken a cement and if you see the cement in the microscope, okay, scanning electron microscope, so we'll be getting this image, and that image is something which describes the size of the cement particles. Suppose when you take a cement powder into your hand, it will be like a powder. But when you see it on a micro scale, can you see the sizes of the cement particles? All these are the sizes of the cement particles, different sizes of the cement particles. So what is the typical size of the cement particles? It ranges between 0.007 to 0.2 mm. It is not even 1 mm. Okay, it is very less than 1 mm. So 0.007 to 0.2 mm will be the typical size of the cement particles. That's how we can determine the size of the cement particles at a micro scale, not at a large scale. This is at a microscopic image, you can say. Fine. And this is one question which we need to address before we close this session. Why gypsum is added to the cement? I was telling that we are going to add 2 to 5% of the gypsum to the cement manufacturing process. The reason for that is the reaction of C3A. This is one of the component that is available in the cement that we'll discuss in the next class. So when you mix cement with water, the reaction will be very fast. So you don't want the reaction too fast. So if you want to slow down that reaction, we are going to add gypsum. So the main function of gypsum is added to the Portland cement to prevent early hardening. Okay, so immediately when you add water to the cement, you don't want cement to get hardened. So you need some time, because let's say you are preparing the concrete. Now you need to transport, you are preparing the concrete at the ground floor, and you need to transport that concrete from ground floor to 10th floor. Now you need some time for that, maybe 5 to 10 minutes of time. So in order to maintain the concrete in a fresh state, okay, in order to prevent the concrete, or in order to prevent the cement to set at a very faster rate, we'll add gypsum. So gypsum will act as a retarder to the cement. That means it will avoid the flash setting to the cement. That because that it acts as a retarder to. I hope you are able to see the screen.
Yeah, screen
Can you
is
please
okay, sir,
check
but
that? Are you able
your
to see my
voice,
screen?
yeah, sir, but your voice is breaking.
Yeah, fine. Yeah, fine. I hope now it is proper. Yeah. So the reason why we are going to add gypsum is we don't want the cement to get set immediately after once it comes in contact with the water. So we need some time for the cement to place in the proper location. So to maintain that time period, in order to set the cement, we are going to add gypsum to the cement manufacturing process. So the typical dosage of gypsum that we used in the cement manufacturing process is 2 to 5%. That's the standard dosage or typical dosage. So that's where we end up with the manufacturing process of cement and the different process of manufacturing of cement, the raw materials that are required to manufacture the cement. So in the next class, what we'll do is we'll discuss about the different cements that are available. So as you were asking some time back, the OPC 33, 43, 53 grade cements, and we'll also see the other classifications of cement in the next class, that is tomorrow's session. So that's from my end for this particular session. If you have any doubts, you can unmute and you can ask.
No, for now it's okay, sir. No doubts.
Yeah, fine. Okay, sure. So I'll do one